All right, we have one more set of notes to do for Chapter 19, and that is on the last part of 19.4, which talks about earthquake forecasting. So, when we're talking about earthquake forecasting, it's important to note right off the bat that there is no completely reliable way to forecast a specific event. Like a lot of other things that we've talked about in this class, there's no way for us to completely pinpoint when and where an earthquake will occur. But what we can do is base those predictions on probability. How likely is it that an earthquake will occur in a certain location and within a certain time frame? So based on probability. Probability is based on two things. So they decide how likely an earthquake is to occur based on the history of earthquakes in that area and the rate at which strain builds up. So they can measure how quickly the strain or stress is building up in the rocks, and they can look at the history of earthquakes in that area and make some basic predictions about whether or not earthquakes are likely for that location and in what time frame. When we talk about seismic risks, we're talking about probability. How likely is it that an earthquake is going to take place? And there are a couple things that we think about when we're talking about seismic risks. You should remember from a previous section that most earthquakes occur in belts. So if you're not in an earthquake belt, you're probably not very likely to have an earthquake. And we also think about past history. So history of past earthquakes is an indicator of future events. Seems pretty simple on the surface, right? Most earthquakes occur in a belt, and if you haven't had any earthquakes before, you're probably not going to have one. They take this data and they use it to create a map, which is known as a seismic risk map. Seismic risk maps show areas of high and low earthquake probability. In the U.S., the places that have high earthquake probability are Alaska, Hawaii, the West Coast, think California, and, strangely, Southern Illinois, and right around Southern Illinois. So states that border Southern Illinois include Missouri and Kentucky and a little bit of Arkansas. So these are the places where the United States has had a history of earthquakes. And if you think about where those are, most of them make sense. Alaska is on a subduction boundary. Hawaii's got volcanoes. Moving magma can cause earthquakes. The west coast of California has the San Andreas Fault. All of those are big plate tectonics, volcanoes, magma kind of associations. So it makes sense that these places have earthquakes. But then you think, Southern Illinois? And it turns out that there's a pretty large fault there called the New Madrid Fault. And we're going to watch a video about that next week. And it'll kind of reenact some of those earthquakes that occurred in the early 1800s. So it's pretty interesting. We also talk about recurrence rates when we talk about seismic risks. And recurrence rates basically give you an idea of how frequently earthquakes occur in a certain location. So a recurrence rate means calculating how many earthquakes occur along a fault in a set period of time. And usually that's years, several decades, or even hundreds of years sometimes. So a recurrence rate would be a magnitude 6 earthquake happens in this spot every roughly 22 years. It tells you about how big the earthquake would be and about how often they occur. We can put recurrence rates together with looking at something called seismic gaps to help us predict which places are going to get earthquakes soon. Seismic gaps are kind of what you would expect them to be based on the name. They're sections along a fault that haven't had an earthquake for a while. Sections along faults that are known to be active but have not had an earthquake in a long time. As a result, seismic gaps are places where earthquakes are likely soon. And I say soon, kind of tongue-in-cheek, soon could be in the next 50 years or in the next 10 years. San Francisco is currently in a seismic gap. The last major earthquake in San Francisco occurred in 1906, and so that's quite some time ago. So we're expecting an earthquake in San Francisco, but that doesn't mean we're expecting it tomorrow. All right, the last thing that we take into account with earthquake forecasting is stress accumulation. So by measuring how the rocks are moving, we can determine the rate at which stress builds up. The faster the stress builds up, the more likely you are to have an earthquake coming soon. And they measure this with GPS. So you can plot the exact location of two sides of a fault and then see, even if it's just moving fractions of an inch every year, you can kind of use that to determine how quickly the stress is accumulating in the rocks. Okay, that is it for the new stuff for section 19.4. Make sure you're catching up with your worksheets and that you've kept up with your notebook. We've got a few more activities to do, and then we will be finishing up this chapter.